Yes. Okay. Yes. Okay, I guess we can start now. So this is the QR code to access this document, which is the document that you usually use for the JuliaHPC monthly meetings. So the idea of this, both was to run one of our usual monthly meetings, but here in person instead of online. But this is also an occasion to remind you that we run every month actually two calls, one more European-friendly time and the other more US-friendly time. You find all this information on the JuliaLang website. If you go to julialang.org/community, there is a calendar of events. Yeah, I think it's the second Thursday of the week is the European time, and the fourth Tuesday of the month, sorry. And the fourth Tuesday of the month is the US friendly time. So if you're interested in using Julia on HPC, please come to these calls and we can chat about stuff. So if you go to this to this document, you can add here the topics that you want to discuss about. This is open, like you can suggest anything you want to talk about, like questions, problems that you encountered, things that you would like to improve, success stories, if you have success stories to share, or yeah, anything like this. Do you have anything to add, Johannes? No. Here's Johannes, sorry. Yeah, maybe a little bit of introduction. Johannes?
Hi, I'm Johannes. I didn't prepare an introduction. I work at NERSC, which is a large supercomputing center that, I should use the mic.
Oh, yeah.
Hi, I'm Johannes. I work at a large supercomputing center for the US Department of Energy, and I think the cool thing that NERSC does is we do the open research part, and also we are not allowed to choose our users, which is a fun challenge. Yeah, and I don't know, I'm involved in Julia because I think it solves a lot of the HPC problems properly.
Yeah, I'm Mose Jordan. I'm a research software engineer at UCL. Yeah, my interest is in Julia and HPC in particular, and I try to help this community going. Yeah. So yeah, start filling this document.
Also, I can be a runner for the mic as well.
Yes. Yeah, if there are questions that you don't want to write down, but.
My internet is a little slow. Grab the microphone.
But I hope that if you scan this already.
So folks want to small group, which means you can actually everyone can talk. Maybe I can volunteer everyone to talk.
Like, why did you come here? Like, you already, like, raise your hands if you are already using Julia on HPC. Okay.
Really? There's people who are interested, but don't use it on HPC. Okay, can I pick on you? Can you maybe tell us whatever you want to tell us about why you are interested in HPC?
Okay, so my background is in high energy fit. So I'm Graham from CERN right now. We'll be moving to DAISY this summer, which are both two big particle physics labs. I'm here because, I'll give two reasons. One is because in particle physics, there are strategic changes which are requiring us to move from large-scale grid distributed computing systems, which are not going away, but to use HPCs more and more. And as a community, we have to think about how we can most effectively do that. So I'm interested in Julia on HPC as a general topic, even though Julia is my hobby horse, not the mainline development of the community. And secondly, I'm interested in HPCs for light sources, because part of my new role at DAISY will be doing a lot of work for the light source community. So I'm interested in experiences that people might have of using HPCs to support photon science as well. So yes, I'm here because I'm interested and happy to contribute any experiences that we have from high energy physics.
Brilliant, thank you. Anyone else want to share their HPC vibes? Are you worried about HPC? Are you new to HPC? Do you think, okay, I can quote one email I got 2 years ago saying, if only you invested all this energy you're investing in Julia in Fortran, then I wouldn't have to learn C++, which I thought was a hilarious thing to say. I asked them, why don't you use Julia? And they said, no, like the vendor, they feel like from the vendor side that they have to use C++ or Fortran, which was a really weird, so anyway, that's an example of a perspective, and I wanted to just like see that. Okay, so if you scroll up to the,
This? The top?
yes. So I like, until people maybe volunteer topics, I like to maybe bring this up. These are sort of evergreen issues, I think. I think I was angry when I made that comment. What is this? Is more about like, huh? So I guess nobody. All right. So is there anything in there that actually tickles people's fancy?
I'm interested in that very first topic about using Julia on a shared file system, because one of the issues I have with using Julia on my cluster is that just starting it up often takes a long time. Like loading packages takes ages, and it's very noticeably slower than loading it on my laptop, for example. And I know that part of this is because of the design of network file systems, like they're not great at dealing with lots of small files. And I wonder if people have found ways around that. I have some colleagues who've experimented with using Docker containers, for example, but this is with Python. Have people done things like that with Julia as well?
I'd actually invite if there's anyone here who's got an answer. No answers.
I'll chip in some experience. So yeah, I think this is a real issue. So we, because of the way high energy physics works, and it's kind of this worldwide collaboration, we actually require a globally distributed file system, which is quite a hard problem, yeah. But we have this terribly good solution called CVMFS, which is this like strongly caching file system that's distributed from a central place, and it goes through a series of HTTP caches right down to the worker node level. What's nice about that is that it will actually cache things on the worker node as well. So yeah, you pay the highest startup cost for the first job that runs on the cluster. But then hopefully the files that you need have been cached a bit closer to where the cluster is. And then subsequent startups on that cluster should be faster. And then when you have the second job that uses the same files on the same worker node, it will be able to get those files locally. So it becomes incredibly fast, actually, at that point. So that's something that we like quite a lot. And we had a summer student worked with me last year on writing pre-compilation files from Julia into CVMFS, and it does work. and we were able to reduce the startup time of simulation jobs in high energy physics from 80 seconds to 2 seconds. So it worked really well and it scales very well. So that's not a piece of work that we've been able to advance much, but I don't know what the state is of CVMFS. I think it's very different on different HPC clusters, whether you're allowed to use it. The problem that we would have with Docker containers is that our software stack is humongous, and so even the startup time for a Docker container on a local high-performance file system is non-trivial, actually. So that's just a bit of experience from our side. So that's certainly a solution I would be keen to help explore a bit more, if it's useful for other people. The downside is it's absolutely read-only by the time it gets into CVMFS. So you have to really know what you're going to run, and you have to prepare your cache appropriately.
Other perspectives?
Maybe I can. So recently I used Julia on Alps, and I surprisingly didn't have any issues. I don't know what they do. Ludovic is not here, but I don't know how, but it was not a problem spawning like 2,000 Julia processes, which again surprised me because I was expecting issues. But I heard that other people having success, which I think is similar to what you were saying, using TMPFS, like you package up your depot in a TMPFS file system, and now in 1.11 we have proper relocatable depots, and that should just work. And yeah, I heard people having success with that, and also this confirms what Graham was saying.
I would, I mean, what Graham pointed out about the read-only caches, that's, I think, speaking to the more general, when you start to peel back the layers of how file systems work, you realize that there are a lot of optimizations you can make, and they require you to make all sorts of different trade-offs. So the general answer I always give is, many HPC system admins, including the people who make Slurm, view the workload running on the HPC resources as one single statically linked executable. How many times I've had to tar up a Julia depot, SB cast it, and then untar it is just shocking, especially seeing that we're in the 21st century. A lot of container runtimes get around this problem by creating read-only file, or not only container runtimes, a lot of centers, and I think Alps does this. You have a file system that becomes read-only on the computes. Once it's read-only on the computes, you don't have to worry about communicating changes to the file system. So ahead of your job, you just cache it on the compute. As long as we can create a good state of the practice to use patterns like that. And I think this is a big problem in HPC because every system is different. And so how do we share this knowledge? How do we say, oh, in Alps, there's this corner there, and on a NERSC, it's like global common software. There's like these different corners which actually perform really, really well. It's just that nobody tells you. That's, I think, a challenge still. I think we do have a website. Nobody contributes to it. So I'm responsible also for not contributing to that website.
Yeah, so there is this juliahpc.github.io website where there are somewhere systems with Julia support, but there should be notes about. Here, yes. So for admins, there is this section about how to provide Julia to users, and maybe there is something about also file system stuff, or maybe it can be added here.
Yeah, so maybe my recommendation to the folks in the room and anyone else who's listening at any point in time is to reach out to us with examples of things that work and don't. And perhaps the problem is we need to put an area there for like half-baked thoughts that other people can build off, because I get an inbox full of ideas and I'm like, yeah, if I only had 48 hours in the day, then I could work on these. So if we could share that work of just spreading, you know, for example, at CVM, I had no idea that you could do precompile with CVMFS. Is that written down somewhere? Ah, perfect. Yeah, so we could add that there, right? Yeah.
So there is something here about place Julia depot on the parallel file system.
Right. But that, yeah, so exactly, here we go. We've got like the Scratch example for NERSC.
Yeah, on apps I was putting in Scratch the depot.
Just like a little thing that maybe people are already doing, but what I did to make it a bit more smoother is to, like in my start script where I submit the job, that I already make sure I run the pre-compilation with the same depot on the login node, that then like, you don't hit too many pre-compilations on the compute nodes, because I think there was some like, relatively recent work to make it better when like, multiple processors are trying to pre-compile the same thing, but I still found that it's a bit like, easier if you have like one process doing most of the pre-compilation stuff.
And you also don't want to pay for.
Yeah.
Some FPC systems give you a finite balance.
Yeah.
Yeah. So about this, in 1.11 there is, I think it's this option, if I remember correctly. Let me enable it. Yeah, so I think it's compile modules equal to strict.
I think like in the past also I just turned off pre-compilation, that then like, so that then like, each node is just doing the compilation and you're not trying to like.
No, so the suggestion is to do it once, if possible, on the login node. And then when you run your job on the compute node, use these compiled modules equal to strict, if I remember is the right one, which errors out if you are trying to load a module which doesn't have a PKG image already. And so it doesn't even try to compile any errors immediately, and so you can immediately see that something is wrong and you can restart your job. Yeah, this was my strategy. So like compile on the login node if possible, and run with compiled modules equal to strict. And in this way, you don't run into the issue of multiple thousands, hundreds of jobs trying to step on each other's toe, yeah.
I had a oh yeah, by the way, the thing that's currently in this space, it's currently keeping me up at night is the topic of cross-compilation. What if your login node isn't the same architecture as your compute node? Yes. But what if all your high-performance file systems on the computes are unsuitable for pre-compilation? You know, these are the sort of things that scare one at night. And the reason why I bring this up is also this is a pattern that we used to have with in the good old days of IBM. Then we were very fortunate at people realizing that it's a horrible design. And now, unfortunately, I think it's due to cost optimization, right? You want your computes to have as slim as possible CPU nowadays, but that's unpractical for the logins. So then you put a nice CPU on the logins, and you're trying to be nice to your users by putting those on. Yeah, so as long as the, so anyway, I think you have more experience with that. Right now, we don't have this problem, but we might have it in the future.
Yeah, so if your login node is the same architecture, but not same microarchitecture as the compute node, follow this. If it's a different architecture, like on Fugaku, for example, the login node is x86, compute nodes are AR64, it's like completely different. There is no way, like you need to do the pre-compilation on a compute node. But yeah, on heterogeneous systems where at least it's the same architecture but not same microarchitecture, there is this environment variable, Julia CPU target that you can set. And this is actually nice. So I think Julia is the only language that I know where multi-versioning is very nice. You don't need to change your code. It's only an option for the compiler where you can automatically compile native code for multiple microarchitectures without, again, changing your code. And yeah, this is super useful. Yeah, see this talk, again, this is on juliahpc.github.io. Yeah, this is very useful for dealing with heterogeneous systems.
And if you have motivated interns who want to help enable proper cross-compilation.
Yeah, that was a question yesterday.
Yeah, I'm happy. I don't have buckets of, I think what they said is if you have bags of cash, we can help you. Don't have bags of cash, but I have open intern positions, so. Anything else? This does not have to be about pre-compilation. Okay.
So this relates to cross-compilation, but for networks, right? Many users will choose UCX or some other network support. And this relates to binary builder. So OpenMPI supports UCX in binary builder. It's configured with it. However, MPitch is not. I think, I don't know, having a vast support matrix in order to have like different configuration options for like just expanding the matrix, I think is important. So you could get the right JLL based off your preferences to support whatever network you have that's configured with. I don't know if anybody else has opinions on this, but that's something I think I want to see.
So honestly, we provide the JLLs only for a starting point, like to have a basic MPI and do something. But if you have strong preferences, you should really use the system MPI. And we provide the option to fall back on that. Yeah, I don't think it's going to be very useful to just build hundreds of different configurations, because with MPI you can
it's
really
a very expansive matrix, but specifically for different networks. I was just assuming that whatever user just doesn't have a local build. And I mean, of course, you could configure your custom build, but.
Yeah, I mean, so HPC usually you do on systems where already MPI is provided. That's the usual case. If that's not the case for you.
Yeah, but if it's a single node with multiple GPUs or something, you're launching multiple MPI procs, but there's a UCX network or something. Something's happening. I don't know. That's the mindset I'm looking at.
So as a follow-up, are you looking at, so you want your, so as Mosé said, the JLLs are there for when you're writing some code, you want to test it on your laptop or like, want to test it locally first. So you're not actually touching the network if you're on a single node, right? So when you're touching the network, I think the MPI community has actually done a lot of progress with the ABI compatibility, so that it is in theory possible, with MPI trampoline, it's practically possible, and then in I'm gonna say like 5 years or so, when like the ABI standard has been adopted already, so we are basically just waiting for the older MPIs to sort of filter out of the ecosystem, and then it's perfectly reasonable for you to take an MPI. I mean, like your MPI code doesn't explicitly talk to UCX anyway, right? So then, if your system has, let's say, it's an NVIDIA system or a Mellanox, and it supports UCX and has UCX pre-configured, then you will just seamlessly use that. And you, I can't. So that's what sort of where the question is. Why you want this? Like,
I think it's more of like a mindset rather than why. So I guess it's reasonable to assume that a user, if they want these feature sets, that they'll have their own custom configuration option. And supplying the capability for the user to like reconfigure however they want, I mean, that's necessary. Instead of trying to support a vast matrix, I think that gets very complicated. So, yeah, so I'll probably just allow users and just keep on using the JLs as defaults. I think that's a good solution in the sense of library developers.
So I was kind of nodding there on the JLL's default thing. So the approach that MPI and CUDA and the approach that I've kind of advocated for is you have global preferences on wherever you run, and then you have like a default that assumes something very local and generic, like a Linux or a Mac. If the HPC center doesn't provide global preferences, then that's kind of their fault, right? They're dropping the ball there. And so, yeah, I would agree with you on that. Yeah. And any other ideas that we should be discussing? Any complaints? No.
Or something that worked well.
Yeah. I will say that I also get emails from users saying like, I really like the fact that you have global preferences and I just go import MPI and I don't have to, like in Oak Ridge, it's like the documentation says run this snippet of code and you can forget that, like, and then your code just won't work. Or your computer just went all matrix. Anyway, so yeah, I also get like people saying it's wonderful that this just works.
So does preferences automatically check the global preferences, like when you check?
Yeah, so I think it's a stack, no? So you have the global, and then if you have a local environment, that takes over the global preferences, but you can have multiple of them, yes.
Okay.
And you can disable that, but like the idea is. Yeah, and that's also what, so the point was like checking preferences, and if there's no preference, then it's a JLL, and yeah.
I didn't realize that.
So one thing that I like a lot about preferences is that in the MPI preferences, you can specify the absolute path to the MPI library that you want to load. And so you don't need to remember to load the module, which I always forget when I do my jobs. Instead, all the information is in the preference file. It finds the MPI library there. I don't need to remember to do module, load, whatever. So that I find very nice.
Also, if people want to share like cool things that they've done. Oh wow, crickets. HPC is not cool. I'm sorry.
Too early in the morning.
I could share my experience setting up Julia on my cluster. Yeah, exactly. This is on Maxwell. And in general, I think it was a good experience. It took a long time to go through the documentation. I had a look at the Julia HPC website. That was quite helpful. I think I spent more time customizing environment variables for individual packages than for Julia itself. So I set up environment variables for things like Python call and revise and so on. Installing CUDA was actually amazingly simple once I figured out the preferences system. Like we also have to manage like GPU-aware PyTorch installations, and those are quite a bit more difficult than using CUDA. So I'm very impressed that this all works so well. Yeah, that's it.
Thanks.
I want to, can you, I want to show something. So thanks, and yeah, I want to show something. If you go to the NERSC documentation, this is the thing that always makes me not like, yeah, and then if you just search for Python in there, yeah, that one I think. And you scroll down. Yeah, they've made it nicer, so now I can try parallel Python in the side panel there. Yeah. Anyway, this used to be, oh yeah, here we go. And then you scroll down to that orange box.
Not here?
Yeah, so there, this is the stuff that this is not even the most egregious thing, but it's like the top line, the gray box, that's the sort of thing that a user would do anyway, because that's what they know. And then they would have had to know to navigate 3 levels steep to find that big orange box telling them to do something slightly different. And then if you, I think, scroll down, oh yeah, install MPI4Py, so there's a whole MPI4Py section. Yeah, if you keep scrolling down a bit, keep going. Oh, go up again. Here, there's another one. Do not do this. And this is really what grinds my gears, because if you're a user from a certain community, you go like, oh, well, I use Conda for everything, so of course I'm going to use Conda for MPI4Py. Now this won't crash. It'll run. It'll give you like 1 million single rank jobs, right? So then you're kind of scratching your head like, why does my equation look funny? And then eventually you get frustrated, you go to the documentation and you have to go like fairly deep, and then you see this box and then you go like, why the fuck hasn't anyone told me this before? And so that's the thing that I really, really don't like. And so that's to talk about the preferences. If other languages had this, right, like this horrible line, right? You have to say MPICC equals yada yada yada, right? Like if you're Python, when I use Julia, I find using the shell like dirty. It's like this Bash is a horrible language. Why do you make me use it? So yeah, anyway, this is sort of my soapbox that like your language, like there should be a standard for the environment, like is it environment variables or something, but there's a standard that every language knows where to look. This is how I'm supposed to run. Or maybe like, sorry, I can't be automatic, so I'm gonna crash and tell the user where to find the docs. But don't just like require the user to have read the manual before doing anything. It's kind of funny also, sorry, one more soapbox thing. People are now complaining that if you ask ChatGPT how to install MPI4Py on an HPC system, like we've got the most documentation, so it tells them to use the NERSC documentation, which is great because if they're not at NERSC, then it won't work. So anyway, I yield the floor. Any other questions, discussion items? If you're, you can ask us, you can complain about things that don't work well. There's lots of things that don't work well, so you can yell at me to close a pull request, something like that.
For list joiners, this is the QR code to access the document where we keep the notes. And you can add things to talk about. Or raise your hand and ask the questions. Question?
Oh, sorry. Wait.
I'll ask a question related to what I was talking about earlier. So, regarding the matrix conversation for MPI JLLs earlier, we have the League8 JLL runtime, and part of it is basically, I mentioned UCX. UCX is a configuration option to supply in the matrix, and my approach was just build every possible combination. There's not too many, and to build UCX, the only way we could do it is with OpenMPI, but if the user has MPitch, then we're out of luck. Should I continue the approach of trying to support? There's not as many configurations as MPI, but there's still like, 4x4. You could expand like over 20 possible combinations or something like that. Should I continue my approach of doing that, or I don't know.
I have a follow-up question. Do you talk to UC? It sounds like you're talking to UCX directly. Is that right?
Yeah, so the Leagate runtime could utilize, it's agnostic to the communication layer. You could configure based on the communication layer. And UCX is one of the configuration parameters. So the goal is, if you configure with UCX, you'll use UCX across your distributed node cluster. Or you could use some other communication protocol. Like we also support Nickel and some others.
Another follow-up. You are building a package called legate.jl, right?
Yeah, we have Leagate JL, and there's also a JLL binary builder package that's based off the C++ runtime, and we configure that, and we link dynamically load to Leagate JL, and then there's a Julia front end for that.
Okay, so you know each other. You're gonna talk, right? Okay. Yes, the Davids will talk. Also, for the record, I think what's happened is a little bit of a confusion. I know, do you know Elliot Slaughter at Slack? Yes, so I've been working with Elliot on the non-Julia side of these things. My recommendation would be for you to use preferences to skip the whole MPI business, right? Like MPI is one transport layer, and it's like, don't worry how it's configured. It's like the MPI transport layer is what you use if your HPC center admin says, I can't be asked to help you configure UCX, so I'm going to insist that you use MPI. There's another name for those. They're cray admins. Sorry, I'm one of them, so I'm allowed to mock them. Anyway, so yeah, you should use in legate.jl preferences to let the system, to let global preferences tell you what the backend is, or the backend of preferences. So.
Yeah, thanks. I had a general question for the audience of what people think is the main impediment to greater Julia use in HPC or or supercomputers in the national labs. Is this, as we were actually discussing a few other times, I mean, at the keynote this morning, the issue with the ability to support GPUs and some of the distributed memories, foreign memory issues with Julia. Is it a technical issue? In other words, do people hear the consensus for this self-selected crowd that an improved implementation of the technology of that support for GPUs or packages would increase the usage? Or is this more an education where people need cookbook recipes, Stack Overflow, general solutions in Julia for their specific problem? Or is it an issue of having Julia being more infused in the basic education at the undergraduate level? So is there any consensus of it's obviously all three would help, but is there any sense of what is the major impediment to greater adoption at the national labs?
I want to expand this beyond the national labs, but if you're asking about the national labs, I think language adoption is often driven, so national labs, so context is mission-driven research. So it means our funder, which is predominantly the taxpayer, gives us a list of priorities we should work on. A really nice example of that was, almost about 10 years ago, they said, well, we want to build an exascale machine. And so your job is to build applications that are just ginormous to use these exascale machines. And then they would give us a bunch of money for that. And the consequence of... So what that means is often you look in your tool chest, what gets us halfway there, because that's the efficient use of money. Whenever you rebuild something from scratch, it's sort of met with raised eyebrows. It's like, why didn't the current existing stuff work? At that point, I think that the things that we can do as a community is, the social aspect, I think, is advocating for why it is necessary to rewrite this Fortran application in Julia now, or the C++ application, or this Python application, right? I'm also thinking, so that's a social side, and I think then the engineering side is, how do we enable interoperability? Because like my personal preference here, or my personal like theory here is rewriting your code in a language to match what the vendor can deliver in terms of performance is a terrible, terrible waste of effort, right? Every time you're rewriting code, you're not building, you're not doing new research. So a language rewrite should be driven by the fact that you look at one language and you go like, heck, I can't express my thoughts in this language, but in this other language I can. That's, I think, the only acceptable time you're going to do that. But too often do we go, oh, we need to do AI now. That's really a thing that the funders are saying. Here's $1 billion, make AI better. And I'm in many conversations where the room says, I hate using Python. It's a weird language. Why is indent? You know, Bob here uses 2 spaces to indent. Gene here uses tabs. Johannes uses 8 spaces. We can't even exchange code. Anyway, and so I think in that, and then I would be like, oh, hey, Julia works great. And they say, yeah, but I can't call my existing tool chains from within there. And so long rambling answer for interoperability, I think, is the important thing there. But I would broaden it. I would say, like, anyone here should be willing to disagree with me, please. I'm also saying controversial things for people to disagree with me, and it doesn't have to be DOE. So you can agree with me. That's lovely. No one disagrees. Come on. All right, I'll say something really, really. Okay. You're saving me from saying controversial things. Thank you.
You can say controversial things later. I'll give you a perspective that I think you get. I think the point that Bob was making is you need a real selling point for people to make a jump from one system that they're using to another, and different motivations appeal to different people. I think what we're trying to do in high energy physics is like tap in at the graduate level, actually, and run more, because there are various schools which are run for computing. Lots of them, of course, concentrate on like high performance C++ now. We're trying to push Julia in there as well as an alternative. And what we've seen is that when people are exposed to both of these things, Julia starts to seem like quite an attractive option. And the other place where we're putting effort in amongst this sort of small but committed group of enthusiasts is in shims. So making it easy for people to interface with existing codes which they have to use, because there's this 4 million line code that's written in C++. No one is going to rewrite that tomorrow in Julia. So if I want to take the output of that into Julia and do some more stuff with it, then I'll try and make sure that you can call it very easily from the Julia side. I guess it's a bit easier in the kind of serial processing world to do that because we don't have to worry about a lot of the things that you need to worry about in HPCs. So, you know, things like providing the website with lots of hints and tips is important, and then supporting people if they are prepared to, you know, put some effort into trying out alternative solutions is good, because, you know, honestly, it's not like people have that easy a time of things if they go for Python or C++. They just run into different problems. So, you know, building a supportive community is also, I think, one of the sociologically important things to do, and making it easy for people to get help as well. But yeah, it's quite hard because I guess in the HPC world, C++ is kind of dominant. In the wider world, Python is the 600-pound gorilla that we're all trying to tackle. Yeah, that's what I'm going to say. Now, please say something more controversial than that.
Yeah, mine is just a question about the community as well. What's the entry points for Julia and the HPC? Is it a graduate level or is it below the graduate level? That also helps to grow the community, to know the entry point to Julia.
I mean, depends on the opportunities that one has, because like if someone is introduced to Julia in undergrad courses, I wish there were more undergrad courses where people will introduce, but I don't think they're super common.
I mean, I think part of the answer is, you know, whether you mean the theoretical entry point or what's the practical entry point now. I mean, theoretically, Julia can be an introductory language as much as Python or C or C++ or anything else, and it's a matter of instilling that into the curriculum and having that be more accessible. I mean, right now, it seems to be the second or third language for people who need a particular, who find it more, better able to express or describe the problems, to implement the solutions. So it's, people are gravitating to it from and I'm not a deep member of the Julia community, but gravitating it more when they, out of curiosity, or that they, through a colleague, through that the team, the department is using it, through that they encounter as people discussing the challenges with some of the other languages and find Julia more conducive to solving it. But I personally believe that injecting Julia earlier into the computational engineering, computational science curriculum is important, so that it becomes more pervasive as just a tool in people's tool belt to use, as opposed to, and it's sort of their familiar language, their go-to language when they have the flexibility to solve a problem, and to just automatically use that language, as opposed to...
Yeah, I mean, to add to your point, I mean, I'm of course biased, I'm here on the stage, so, but like, I really think that Julia is a very good language for introducing people to programming, and what I like especially about it is that you can go as deep as you want to learn more and more about optimization, because like you can start using it as Python, like just as a scripting language to do something simple, but then you can also in the same language learn about optimization, like and care about performance and what you need to do to optimize your code. Because I see courses where they, maybe the main part of the course is in Python, because that's what they want to teach to beginners, but then for the performance, they need to do something else. Or maybe they talk about MPI for Pi, but say, yeah, no, I mean, you're not gonna really run MPI, Python code with MPI, because otherwise you just have hundreds of cores doing something very slow. So anyway, you need to call something else. Again, inside in Julia, you can do all these gradual descent into madness, but like go and learn more and more about performance and staying within the same framework instead of doing introductory part in one language and something else in another one. So I completely agree with you that it's from a learning point of view, it would be really a good language, but I don't think it's super common at the moment, unfortunately.
Maybe I'll add to that and say I learned Julia during so while I was at university, actually doing a postdoc, and then it sort of just simmered in the back of my mind. But it's like the tool belt theory, right? Like you give people a tool belt full of tools, and like actually before someone uses the right tool, they need to know what it feels like to use the wrong tool. And so building up to my controversial statement, so at some point I was running CFD simulations, and the simulation would take 1 day to run, and the Python script to analyze it would take 4 days. And then I looked at optimizing it, and then I always ran into like, oh, well, to optimize Python code at some point, it's like, oh, just use this library from this vendor. But no, sorry, you know, NumPy wasn't right. Okay, fine, I'm going to use CuPy. Oh, but then this machine doesn't, you know, have GPUs, or like that time CuPy didn't do AMD GPUs. Anyway, the point is, I realized that I had to rewrite the script and try all these different languages. And at that stage, I'm like, I would have saved a lot of time if I had just rewritten the whole damn thing at the beginning in Julia, right? And so my controversial statement here is, and I always like to egg people on at NERSC with this. They ask me, why do you care about Julia at NERSC? And I'm just saying, well, most of the Python stuff we run at NERSC, if we replaced it with Julia, users would be more productive, and we would have to do a lot less work supporting them through the painful process of realizing that their favorite library doesn't work here, or that they have to find the magic shell command to pre-configure it. And so part of that, though, I think, is they have to feel what it's like to fail at using the first tool they want to use. And we have to be ready to be like, let me help you there with this other cool thing. Any other thoughts? By the way, the first language I learned was Java. And that was, I came to the HPC Center, I'm like, I want to run this Java program. Everyone looked at me, was like, what the hell are you doing? Sorry. Yeah. Oh, fuck. I didn't see the time. Any closing thoughts? Anything else that people want to share? Comments? Please for help. No? Okay, so I don't even start to pick on vendors. That's great. Yes.
Yeah, just as a reminder again, if you go to the julialang.org/community website and scroll down, there is a calendar with events, and there are 2 monthly calls about Julian HPC, so if you want to engage with the community, please join us. Find the time that suits you best. We try to cover different time zones. Yeah, please join us. And we can continue talking about this stuff and how to best support community and so on. Question?
This is first time to attend this Julia HPC. I am a HPC user I'm working for Lattice QCD, high energy physics. And I'm using Julia on, leadership class supercomputer. And so in my, community, no one uses Julia, only me. And the problem in Japan, I'm in Japan, and the problem in Japan is that the system engineer don't understand Julia, how to install it. And actually my collaborator is one of the best person who asked. And he's a researcher, but the system engineer asked him how Julia install. So I don't know where can I get such kind of information installing Julia in HPC, a super large scale computer.
So I think you joined later. So there is this website, juliahpc.github.io, which has information also for system admins of how to provide Julia to users and how to manage packages or not manage packages. Yeah. So you can find more information on this website.
I promise to contribute more to that too, but also one thing I do as an admin is I readily and happily take calls from other data centers and walk them through. It's a painful process, not because of Julia, it's just installing anything on these systems is painful. And so being present and patient while someone realizes that they don't have the right Unix file permissions and they got to follow up with their colleagues and then get back to you tomorrow. That's part of the modus operandi. And so I'm happy to get in touch with people, and also if you know other sysadmins, if you're a Julia sysadmin and you find another sysadmin that's interested in Julia, it's wonderful. Yeah. So yes, 1 minute left. I am being. So yeah, thank you all. It's always a pleasure talking about Julia and HPC, and I hope to see you around online and future JuliaCons, and maybe the HPC call.
Thank you. Thank you.
I will add one more fun thing. Often I hear from people, I want to learn Python because all the job ads are asking for Python. It's actually, nowadays you see CVs and everyone puts Python down. So when someone says, I know Julia, it's like, I'm gonna take that interview. I wanna meet this person. So. Testing.